Hello, it's Dr. B. Today's May 7th. Your gas property lab simulation is due today. Today you have homework that'll be due on May 11th, and it deals with Boyle's Law and Charles's Law. Notice the meme on the side over there. So both Captain Americas, they're both equal, but they have different values. So that's what our lecture is going to be partly based on today. So, properties of gases, we'll cover that first. There are four of them you should be aware of. Okay, so first one, gases completely fill the container that holds them. They can be compressed or expanded, just depends on whatever you're dealing with. They will spontaneously mix with one another, and they exert a constant uniform pressure in all directions simultaneously. So these are just things to kind of keep in mind, especially I would say probably number two, because that's what the gas laws we're going to be dealing with. That's what they kind of look at when we talk about volume. So first thing, because gases can change their volume, like we talked about before, we're going to focus on how pressure, temperature, and the amount of gas can affect the volume with different gas laws. There are a handful that you're going to have to keep in mind, and you don't have to memorize them, obviously. On the back of your periodic table, there's a few that are listed. You just have to be able to recognize them at least and plug in the numbers correctly. So first thing we're going to look at is pressure. A gas exerts its pressure as its molecules collide with the surface of the container that it holds. So the pressure, like in a tire, pressure in this, pressure in that, that means that the molecules are hitting each other and pushing against the container itself. That's what the pressure is. So if you increase the pressure in a tire, or your volume of gas in a tire, that means that the pressure will increase. So the formula for pressure, it's force of the impacts of the molecules divided by the area. So pressure equals force divided by area. So I want you to keep this in mind when we go to the next slide, okay? Because that will hopefully make a certain example make sense. So for example, increase your volume of gas in a tire, you increase the pressure because there are more molecules being pushed against it. As you move away from the surface of the earth, the pressure decreases. The air becomes thinner because there are less collisions of the molecules. So this is what I was talking about. So you see this right here, and then all this right here. So looking at if pressure is force over area. So let's say that these two are the same people, for example, which they're not, but let's just say they are hypothetically. So they have the same amount of force. If that force is spread over a large area, that means you have a lot of force over a big area. You divide the two numbers, that means it should be less pressure. However, if the same force goes on a small area, so a decreased area, that means a lot of pressure right there. That's why people are able to lay on a bed of nails and not feel a thing, but it hurts to step on a rusty nail or a nail sticking out like that. And if you want to look more into that, rusty nails and all that, you can YouTube or Google tetanus, and that will talk about that as well. All right, so a barometer is used to measure pressure. So there's a video called The History of the Barometer that I want you to watch. That's just some good information, if you will, and it also provides a lot of information for the different units of pressure. So the way that it works is that at a certain elevation, there's a certain amount of atmospheric pressure, or certain pressure. So what happens is that it will push against this container filled with mercury, and the mercury go up a certain height. And the units for mercury in terms of pressure is millimeters of mercury. So at sea level, this height will be 760 millimeters of mercury. So that is 1 atmosphere. As the video says, you can go to different elevations, and the higher you go, the pressure will actually be less. That's why we know that the higher the elevation, the less the pressure, because of the less molecules, the less collisions there are, etc. So that's how the barometer works. So looking at this, there's a lot of values here on the bottom, and they all equal each other. So for example, looking at this, 1 atmosphere is 760 millimeters of mercury, is 760 torr, which is named after Torricelli. Pascal, so this is named after somebody else. 1.013 times 10 to the 5, and then kilopascals, 101.3 kilopascals is 1 atmosphere. So these all equal each other. That means that you're going to have to convert these. Alrighty, so 485 millimeters of mercury to atmosphere. So you can do stoichiometry with this. So 485 millimeters of mercury. So you know, in 1 atmosphere, it's 760 millimeters of mercury. So the units cancel out, then you just do your math. 485 divided by 760, 06.38. 556 torr and 760 torr. That is 101.3 kilopascals. So 556 times 101.3 divided by 760, 74.1. 2.50 atmospheres. In 1 atmosphere, it's 760 torr. So 2.5 times 760, that equals 1900 torr. So that's pretty simple. That's not too bad, actually. Something that you should already know to do, etc. Moving on. When we're dealing with gases, temperature needs to be in Kelvin. You should know how to convert that already. So it is degrees Celsius plus 273 equals whatever Kelvin that is. So again, there is no degree symbol when we use Kelvin, so keep that in mind, okay?